everyone, welcome to Maths IAC. Here's another exam style question for A-level physics. Three identical cells of EMF E and our internal resistance R are connected in parallel. A resistor of resistance capital R is connected as shown. Find an expression for the current in the circuit. Pause the video and give it a try. When you're ready to check the answer, press play. Let's take the current in this external circuit to be capital I. So the current goes through this, through that, and like that. Now, to calculate the current, all we need is EMF divided by the total resistance in the circuit like this. I is equal to E over R plus R. If you think about two cells of EMF E, and that are connected in series like that, then if that is A, this is A, then the overall is 2. However, when you have a parallel combination like that, the EMF provided by both of them is still E. Now, so one might ask, okay, so what's the difference between a single one like that and this one above it? Well, the difference is if you use the top arrangement, let's imagine imagine R to be 0 here, right? Let's imagine in both cases. I'm not really talking about this question. What is in green is just a separate explanation. Okay. Now, the way the difference between these two is the top circuit will be able to power this light bulb for twice the time that the lower circuit can work. Those are just some extra things that I mentioned, not exactly a part of this question. So let's go back to this. Now, the EMF is E, the total resistance. So the total resistance is externally is capital R. Now we need to get the combination of these three lowercase r's. Now, three identical resistors, so the total resistance of these three is R over 3. Now, well, if you wonder where this came from, all we need to do is just use 1 over R total is equal to 1 over lowercase r, one of them, plus 1 over lowercase r plus 1 over lowercase r. So 1 over R total is 3 over R. So R total is R over 3. But you don't really need to do that. You can straight away get this, because we know when you have a number of identical resistors connected in parallel, the total resistance is the resistance of one of them divided by the number of resistors. In this case, R divided by 3. I did a separate video on this somewhere in the playlist. You can have a look at it if you want to get familiar with that one. So this is R over 3. Now, we just need a little bit of simplification to get the final expression. Now, let's get the common denominator of the bottom one to be 3. And this is 3R plus lowercase r. Now, this 3 can go to the top. So, it's E divided by that is the same as times by 3 over 3R plus R. So my final expression is 3 capital E divided by 3 capital R plus lowercase r. That is the final answer.